Generally, while designing any big software, we use layering approach, which means we are going to divide all the tasks into various groups, and some group of tasks will be assigned for some layer to implement, right? So why do we use this is we want to have some kind of abstraction. Whenever you have many layers of software, later when you try to modify one layer, you need not modify the code in the other layer, right? So changing the functionality later will be easy. So most of the operating systems, they follow this layering approach, coming to all the parts including file system. So in file system we are going to have various layers. Now every layer is responsible for some activity. I'll show you with example how or what will happen exactly when a user asks for a file, okay, or any operation on the file, whether to create a new file or read from it or append to it. I'll tell you what happens exactly, okay. So let's see this. So file systems provide efficient and convenient access to the disk by allowing data to be stored, located and retrieved easily. So its main purpose is to store the data and then locate the data and then retrieve the data. So when you try to create a file, we should be able to store it on the disk, and later we should be able to locate where it has been stored, and later we should be able to retrieve it. This is the main thing. Now how it is being done, we shall see it, okay. Now let us say this is the flow which we are going to follow, right? So our file system is going to be classified into various layers, and each layer is also named, and each layer has specific responsibilities. First thing is, when an application program asks for a file, whether to create a file or to delete a file or to append to it or read from it, whatever the operation, it is going to ask, and the first request will be directed to the logical file system. Now the logical file system is going to have the metadata. Metadata means data about the data. Already file contains the data, and if you maintain the data about the file, that is called the metadata, like who is the owner, when it is created, and what are the permissions on the file. Let us say some user is trying to execute a file, and if he is not having the execute permission on that file, then at this level only we are going to give an error saying that you don't have the permission to retrieve the file or execute the file. Got it? And directory structure also is going to be managed by the logical file system. So what is the directory structure? You know this, it is a kind of tree, right? So you are going to have various directories listed, and finally every directory is going to have even more directories, and finally somewhere you are going to have files, right? So this is the kind of directory structure we are talking about. Now whenever you have a directory structure, right, whenever you ask for a file, you should be able to locate which file you are actually requesting, right? Sometimes you may not actually specify the absolute name. Absolute name means absolute path. You need not say the entire path where the file is. You may sometimes use a shorthand notation, right, like symbolic names, or you might use the current directory, and from the current directory you might try to access a file. Therefore whatever name you specify, finally you have to identify which file you are going to ask in the directory structure, and this entire directory structure is being maintained by the logical file system. So it will try to find out which file you are actually asking for in the directory, and once you specify the file, next thing is, a file is actually divided into blocks, and each block is numbered. Let us say this is file 1 you are talking about, and this is block 0, block 1, block 2, block 3, right? Even though the blocks are numbered like 0, 1, 2, 3, these are all the logical numbers. Physically when you store a file, it will be stored on a disk, right? And a disk will have many tracks, isn't it? And a track, and then many sectors, and each logical block may be actually located onto some physical block, right? So there has to be some mapping. Even though you are asking for file number 1 is a collection of blocks, and all these blocks are present on the hard disk, and you have to map them. So what does it mean by block number 0 of F1? It might mean that we are actually asking for maybe block number 10 of the hard disk, and sometimes there will even be something called as cylinders, right? So you might have a cylinder, and within a cylinder you might have tracks, and again within a surface. So there are many things going to be there. So you have to map the logical block into physical block. So that is being done by the file organization module. Now this is going to have logical block to physical block mapping, right? And let us say you want to create a new file. In that case, you have to find out what are all the free blocks available on the disk, and let us say there is a free block, right? Then you are supposed to get it, and into that you are supposed to write some data. Now even that free space management is also being done by file organization module. Got it? Okay. Now once you have decided about what are all the the memory blocks that you need, or the hard disk physical blocks that you need, you pass this information to the basic file structure. Now the basic file system, it is going to issue the commands to the IO control in order to fetch those blocks. Getting this? Now let us say this is the block you want from the hard disk. Now you are supposed to fetch this block from the hard disk. Now when you fetch this block, you are supposed to save it in the memory, main memory, for the CPU to access, right? So that you can open it, you can read it or write it, whatever you want to do. So for that reason, you need to have some buffers in the main memory, right? So that is called as buffer. Buffer means some temporary storage or temporary space into which you have to store this, right? The temporary space is also being managed by the basic file system. Now basic file system will issue the commands to the IO control. Now IO control will contain the code using which it can access the hard disk, right? They are called as device drivers. So device drivers will be helpful in accessing the secondary disk, this one. So from this, in order to get it, you are supposed to issue the commands. Those commands will be given by the basic file system. Using those commands, the device drivers are going to get the data, and then after getting the data, you are supposed to put it in some buffers, and that is being done by this one only, basic file system. Got it? And then you have to even manage the interrupts, and the interrupts are being managed by the interrupt handlers. So why do we need interrupts? About this we have discussed about this in CO. So what is an interrupt? The speed of hard disk is going to be very less compared to the speed of the CPU. So while the data is being fetched, you need not look at the data, or you can do some other work. So once the data is completely available, then only you are going to look at the hard disk, right? So for that reason, we are going to use something called as interrupts. So interrupts are a way by which the CPU will get disturbed once the work is done by the secondary hard disk, which is slow, right? About this we had spoken about this in CO. We discussed about this in detail there. Okay. And finally, IO control is going to access the device. Got it? So the data, whatever is present here in the devices, will be first buffered by this, and from this you are going to get it. Got it? So this is how the entire file system is layered. So this layered organization is going to help us in further modifications. For example, if you want to change some, let us say some module in this, right? It will not affect either the code present here or the code present here. That is why we go for the layered organization. Okay, fine.